Hey guys, I need to do some housekeeping real fast. Hold on. Yeah, can you hear me now? Like, give me a thumbs up if you guys can hear me. Okay, good. The okay. So first off, on the test, I believe it was this class, but if you look at number 4, and I want you to go back and look at it. Number 4, I believe, had kind of 2 answers that could be considered correct. It was either like a none or a none of the above. Just go back and check it. And if Blackboard counted it wrong, let me know. It's a quick process for me to go in there and just kind of change that to correct if I need to. I know some of you emailed me last night, and I haven't got to those emails yet. I've been busy all morning, and I'll get to them as soon as I can. But look at number 4 on the test, and if you got it wrong, because it counted either none or none of the above was the correct or wrong answer, get back with me, and I don't mind changing that. I know that was just a goofy mistake on really my part. It's not Blackboard's fault. That's my part. Okay. Does anybody else have questions before we get going on 3.1? Just kind of housekeeping type questions. Okay. Let's get rock and rolling. Hold on, let me get this back to the other camera. Whoop, there we go. Okay. So yeah, question number 4 I went over. Today we're going to go over section 3.1. Now I'm going to tell you this next test is over 3.1, 2, 3, and 4. 3.1 is the only one that kind of sets out by itself. There's just no great way to put it in any part of the book, so I understand why he has it here, but it's just over quadratics. We're going to spend all day today talking about quadratics, quadratic equations, quadratic functions, quadratic graphs. It's the day of quadratics. Okay. Okay. And before we really get into this, we're going to talk about the graph first and just describing things on the graph of a quadratic. And we know what they kind of look like. Remember that standard quadratic? We drew it a lot. Now I'm going to draw one that's not a standard quadratic, but one that's been shifted. Can you see that up there? Okay. Let's say we've got this quadratic. 1, 2, 3, 1, 2, something like this. And let's say it goes to right here, and it's flipped down. And it looks something like this, okay? Now, look, one nice thing about quadratics is they're always symmetric. And they're always symmetric around something called the axis of symmetry, okay? This axis of symmetry will always split. Now, I know here it's not perfect, but in reality, there is a perfect symmetry around that line. This line is called the axis of symmetry. In your book, your author, Dr. Blitzer, he just, for some reason, enjoys that line. It's not in a lot of books. He's a different kind of guy. If you flip over your book to the very beginning introduction, the book that I've chosen that he wrote is actually dedicated to his horse, Jared. So if you get a chance, you can flip it all the way to the front. And he did write this edition of the book for Jared. But anyway, that's the axis of symmetry. Now, where the quadratic either goes from increasing to decreasing, or, if this was flipped over, it would be decreasing to increasing. That switch right there, that is called the vertex. Okay, that's called the vertex. Now, for us in this example, the vertex is what? 3, 2. Okay, just for our example, the vertex is 3, 2. Now, the axis of symmetry is always a vertical line that goes through the x value of the vertex. So a vertical line is always x equals a number. So it's always x equals whatever the x value of the vertex is. So for our example here, the axis of symmetry would be x equals 3. Okay? No big deal. So now, a few other things just that are common to ask with the quadratics, really kind of with anything. If we ask domain and range, which we've talked about in the past. I believe we have, yeah. The domain, now what's nice about quadratics is the domain is always all real numbers, always, okay? It goes to the left forever and it goes to the right forever. So you can write this. Now, of course, in interval notation, it's written like this. Now you might see me do a more efficient shorthand of this, which is just R, and I'm not sure if we've talked about that. This means all real numbers, okay? In mathematics, it's a mathematical kind of shorthand way of saying all real numbers. So you might see me use that a little bit today because I just don't want to write the infinities over and over again. So if you see it, it's that paragraph indentation symbol in English, but instead of a P, it's an R, okay? And that means all real numbers. Now, the range though on these is not all real numbers because it either goes up and then down or down and then up. It's gonna have to stop and go back the other way it came from. So if we look at range here, this goes down forever. So it does go to negative infinity, but it stops. Now it's always gonna stop either down or up at the Y value of that vertex. So for this one, it stops going up at Y equals 2 here, right? At Y equals 2. And you know, we exist there, so we're gonna use a bracket. So negative infinity to 2. Okay, questions about this? It's not that bad. It's just more descriptors, right? The axis of symmetry of vertex might not be something you've seen before, but it's just descriptors of something that we kind of know already, okay? We kind of know these already. And we'll talk about these with our examples. This will be part of the examples we go through today. Okay, good. So let's talk about this. Now look, there's two ways to write a quadratic equation or quadratic function, I should say now. The first way your book goes over, it starts on the bottom of page 331 and kind of goes to the next page. And your book calls it standard form, okay? Standard form. So standard form, you can say standard form of a quadratic, that would be fine too. And it really is that kind of transformation form that we're familiar with from the last test. Okay, it looks like this. F of x equals a times x minus h squared plus k, okay? So this is called standard form. Now, what's really nice about standard form is it tells us the vertex. We know this already because think about it. If h and k are numbers, okay, so is a, but h and k are numbers. And if we were shifting here, x minus h means we go to the right h units, right? And then k means we go up or down so many units. So this h and k turns out to be our vertex. And in other textbooks, they call this something like vertex form or transformation form. That's why. We know that part already. Once you see an example of this, you'll go, oh yeah, I knew that. Okay. Now the A though, we didn't talk about stretching or shrinking, which is fine. It's not going to affect us here. But this A tells us really if we stretch it or shrink it. I'm not worried about that. What I'm more worried about is the sign of A. So the sign of A tells us if the vertex is a max or a min. And again, we know this already, so I just want to review about it just a little bit, okay? Now think about this. If this A is negative, say it was like negative, just negative, okay? Remember that meant we reflected around the x-axis. So if this A is negative, we reflect around the x-axis, and we have something actually that looks like our example before. So if the A is negative, we have a graph that looks something like this, and it makes our vertex here a maximum, right? So if A is negative, we have a maximum vertex. Now, if A is positive, we have a minimum vertex, okay? And vice versa. Now, I'm not saying you have to memorize these. It's just something that is we need to know when we're kind of graphing them, because when we do a vice versa aspect, when I give you a graph, you need to realize, hey, that means the A is negative. Or it means the A value is positive. Okay, so let's look at one of these and just kind of graph it a little bit on what we know from the last test. So g of x equals, let's do 2 times x minus, let's do x plus 3 squared. Let's say minus 4, okay? And I'm not going to do a perfect graph. That's not what I'm about here. I just want to get a graph that kind of shows what this looks like. And we're going to pull out the vertex axis of symmetry. And then, yeah, we'll just do vertex. Oh, and domain and range. Okay. So let's graph this thing. First off, if I gave you this graph and I asked you for the vertex, remember the +3 means we go to the left 3 units, right? So your x value or your vertex is always the opposite of this sign. That's why it's written as a minus h there. Okay. So the +3, remember we go to the left 3. So that means we're going to go to the left 3 units. And then the k is -4. So we're going to go down 4 units, right? So we go to the left 3. We go down 4, 1, 2, 3, 4. And we know our vertex is going to be right there. So next I'm going to ask, hey, is this vertex a minimum or a maximum? I'm probably going to ask you why too as well. So is this a min or a max? Well, okay, notice the a value here is 2. So that means we're not flipping this down here. It's not going to be a frowning quadratic. It's going to be a smiling quadratic. Because it's smiling here, it means that that vertex is going to be a minimum, right? And why? It's because a is positive. Excuse me, a is positive. So therefore, we're going to have a minimum vertex. Okay, so I'm going to just kind of make, this is a rough sketch. Okay, rough sketch. We don't know any other points yet. We'll go into finding other points in the next example. But we would have something that looked like, I'm going to say it's probably like a little tight equation here. It'll look something like that. Okay. So next we've got axis of symmetry. Well, the axis of symmetry, it's a vertical line that goes through the vertex, right? Vertical line that goes through the vertex. Now our vertex, our x value is -3. Vertical lines are always x equals. So x equals -3, okay? That would be our axis of symmetry. And now looking at this thing, I'm going to ask I'm just going to write D for domain and range. I'm going to be a little lazy or efficient, as we say in mathematics. Domain, look, always all real numbers, okay? Moving on. Range, though, is different than the last example, right? For this one, the range goes forever up, but it does stop coming down. And it goes down to -4 because that's the minimum, right? So it goes down to -4 and it goes up forever. So down to -4 and then up forever. So -4 to infinity. Okay. Guys, any questions about this? It's not that bad. I'm going to add like I'm going to add some stuff that's going to be more important for the next 3 sections. Moving on, okay? But do you guys have any questions about this before I keep rocking and rolling?
I have a question.
I'm back. Okay, what's up?
The -3 in the vertex, okay, it's a positive in the other one, right?
Yeah, like
x.
Yeah, right here.
Yeah, so what did you say makes it a negative?
No, remember, okay, I want you to think back to like section 2.7 that we just tested. Remember, if it was +3, it shifted to the left 3 units. So really, whatever sign this is, for the x value, you always change it.
Oh,
so
okay.
If it's a +3, it's going to be a -3. Now look, the y value is going to keep whatever that number is, that's going to be the same. Okay. But the h value always switches.
Okay, thank you.
Yeah, no problem. Does that help?
Yes.
Perfect. Any other questions? Great. Okay, so let's do another one of these, and I'm going to ask you like A, B, C, D, E, F, G on these, okay? So let's see. We've got, I'll make one up. Let's say G of X equals, and we'll do -2 X minus 4 squared. Let's say I'm going to make one that kind of works. Let's say plus, let's say +8. I think this will work. We'll see. Yeah, +8. So -2 X minus 4 squared plus 8. And now I'm going to ask you a lot of stuff here, okay? And if you want to start answering these as I'm going, that's fine. But I'm going to kind of fill up this page with just questions. First, I'm going to ask, what's the axis of, or I'm sorry, what's a vertex? What's the vertex here? And then with that, I want to know if it's a min or a max before I graph it, okay? Min or a max before I graph it. B, I'm going to ask, what's the axis of symmetry? Axis of symmetry. C, we want a few more coordinates to graph this a little better. So, and this is what we really need to know for the next few chapters or few sections. C, I'm going to ask you, what's the x-intercepts? That might take a little space. Actually, maybe we'll see. I'll do D down here. Well, y-intercept. A, B, C, D, E. Oh, let's do domain and range. We know domain already. Let's just do domain. Do range. And then let's do a little better graph then. So now that we know, we'll know a few more coordinates. Robert, let's graph this thing. Okay. So I'm going to work through these. You can work ahead and see if you get the same thing. That'd be great, actually. Let's see the vertex. Now look, that -4 means we need to go to the right 4. +8 means we go up 8, right? So the vertex is 4, 8. If you want to graph these as we're going along, that's fine too. You know what? We've got. So I'm going to go over 4 and then up 8, right? 1, 2, 3, 4, 5, 7, 8. So 4, 8, about right there's going to be my vertex. And I know that this vertex is going to be a maximum because A is negative. So A is negative, so I know that that's going to be a max. So we're going to come down, right? We're going to come down. Axis of symmetry, very straightforward. Always X equals, because it's a vertical line, X equals 4, okay? If you want to draw a dotted line here, that's fine. You're more than welcome to. You don't have to, though. If you want to draw the dotted line, that's fine. X-intercepts, though. Now, okay, look. I'm going to sit here and talk about x-intercepts for a minute because that's going to be so important in sections 3.2, 3.3, and 3.4. X-intercepts are where your function equals 0, okay? Remember, if you want to find it like how you learned how to find them back in like kind of basic algebra, it's where y equals 0, okay? It's where y equals 0. Well, now y is this entire function, right? This is a fancy way to say y. It's this entire function. So if I want to find the x-intercepts, I'm going to set this entire function equal to 0, okay? Now I've got to solve this out. Now, if you forgot how to solve this, I think we went over this in the very beginning of this class on how to solve square roots, but I'm going to kind of go, I'll go a little slower on this first one if you don't remember that. So the first thing we need to do is subtract the 8 over, so we get -2 times x minus 4 squared equals -8. Then we've got to divide the -2 because in this square root method, we have to get this x minus 4 by itself. So we wind up with x minus 4 squared equals +4, right? So then I'm going to take the square root of both sides. But when I do that, I have to remember a plus or minus, okay? I have to remember a plus or minus. So I wind up with x minus 4 equals plus or minus, I know the square root of 4, right? 2. So look, I've got, add the 4 over. I have two solutions. I'm running out of room here, but I've got two equations going on. I've got x equals 4 plus 2 and x equals 4 minus 2, right? 4 plus 2, 4 minus 2. So you wind up with x equals 6 and x equals 2. I know I ran out of room. I knew this was going to take me a little more room. I didn't realize it would be this much. Now these are intercepts, so I have to write them as such. So this would be 6, 0 and 2, 0. So 6, 0, 2, 0. I'm going to graph this. So there's my one of my x-intercepts. There's my other x-intercept. Okay. Questions about that? Now, I think we went over that at the beginning of the semester, and but it comes back here, and it's going to come back in 3, 2, 3, 3, and 3, 4 as well. Okay, let's do y-intercept now. For y-intercept, it's you've got to plug in x equals 0. Okay, which is nice. If we go back to our original equation, you just plug in x equals 0. Okay, so let's see here. This would be not 0 minus 4. So that would be -2 times -4 squared plus 8. -4 squared is a positive 16 times a -2. That's -32 plus 8. So this winds up being 24, -24. Ooh, I'm not going to graph that. Okay. But our y-intercept would be 0, -24. Okay. It's like way down here somewhere, right? We kept going down. Somewhere down there. Yeah, we can kind of graph this now, okay? I can get a pretty good idea of what this looks like. And it looks something like this, right? Holy cow, that's a pretty decent graph. Uh-oh. Hold on. Hold on. I got an Amber alert going on. Wow, that's crazy. Is my phone on silent? Okay. Okay, so let's get back to this. Sorry, guys. If we want to answer the domain and range question, again, the domain is going to be all real numbers, right? That's going to be the same every time. The range, though, goes down forever, and then it stops at this peak, right? Now, this peak is a vertex. So it peaks at y equals 8, up there. So it goes from -infinity to 8, like that, right? Sweet. And we're done. Now, if you wanted to graph the axis of symmetry, it goes through x equals 4, right? So it looks something like that. And that's fine. You don't have to, though. I mean, and remember, this is multiple choice. It's going to be more about matching it, okay, than anything else. So questions about that example. I'm going to have you try one on the next one by yourself. But we're going to answer that same A through G questions, okay? Any question? I'm going to slow down for a second. Okay, so let's try this one. Let's try g of x. I'm going to move this to kind of. Let's try g of x. And let's do x minus, or let's say plus 2 squared. Let's say plus 3. Why not? So if you want to start working on this one, I want you to find the vertex. And again, max or min. B is axis of symmetry. C, I want you to find the x-intercepts. And then I'm going to give you a big gap here, right? Because it took us a little longer there. And then A, B, C, D, I want you to find the y-intercept. Now look, we're always going to have a y-intercept because our domain is forever to the left and right. Remember, the x-intercept's when x equals 0. I'm sorry, the y-intercept is when x equals 0. Well, you're always going to be able to plug in x equals 0 because the domain's all real numbers. So the domain will always include 0. So the y-intercept, you'll always have a y-intercept. Okay, so A, B, C, D. E, we'll do domain. I don't know why I even asked that now. We know the answer. Range, though, we don't. And then G, let's graph this thing. Okay, I'm going to give you a few minutes. Question mark, that's a statement. So I'm going to give you a few minutes to work through these on your own and see what's happening. Okay, I'm going to start. Keep working. I'm going to just start on this. Let's see. On the vertex, look, we know we go to the left 2 and then up 3. Okay. Left 2, up 3. Oh, this is going to be a minimum, right? Because the A is positive. A is just positive 1. Axis of symmetry would be x equals -2, right? I mean, if you want to graph it, it'll look like that. X-intercepts. Okay, let's start solving this. Now look, intuitively, from what we know so far, we know this thing is not going to cross the x-axis, right? If this is a minimum, this is going to go up. I want to show you what happens, though, with your x-intercepts if we don't cross it. If I set this entire thing equal to 0, like we did on the last example, to solve it, we got to move the 3 over. We take the square root of both sides, attach the plus or minus, okay? What you'll notice is you end up with an imaginary number here. The square root of a negative is imaginary. So what that means is we do not have a real intercept, okay? We could stop here. I'm going to solve this one out just because I feel like I need to. Remember, you take the I out if it's underneath the radical. And then we get -2 plus or minus I squared root of 3. Now, this is a real graph. It is real X and Y numbers, okay? It's real number lines. There is a non-real graph. If you ever want to get into higher level mathematics, there's a non-real, it's called a complex graph, where the X values are actually the real values and the Y values are the imaginaries. We do not have that here, though. So because of that, we can't graph -2 plus or minus I squared root of 3. So therefore, that's what'll happen if you don't have intercepts. So for intercepts, you can put a circle with a line through it. They just don't exist, right? That means the null set, no solution. For now, okay? I'll tell you, for now. Now, the y-intercept, though, we're going to solve this thing out. So remember, we set x equal to 0. End up being like 7. So 2 squared plus 3. Yeah, that's just 4 plus 3. So we wind up with 7. So 0, 7. So 1, 2, 3, 4, 5, 6, 7. Now remember, there is symmetry here. So if I know that there's a 7, if there's a coordinate here, on the same height on the other side, I know there must be another coordinate, right? Because of symmetry. So that's kind of nice if you want to use it to get another coordinate going on. We've got something that looks like that. Kind of neat. Domain, easiest point on the test. Range, though, again, it goes up forever, but it stops. We've got a minimum at the vertex, which was 3. So it's going to be 3 to infinity. Oh, not negative, but positive 3 to infinity. Okay. And we graphed it. Great. Sweet. Questions, comments? So this one's a little different because we didn't go through the x-axis. We'll always go through the y-axis. Okay. You'll always have the y-intercept. Make sense? It's not too crazy. It's a lot, right? I mean, we're kind of going above and beyond than just solving these things, which is good. We need to know what they look like. Okay. Let's talk about the other form now, and we can do a few examples out of it. And the other form, I'll tell you, it's a little more frustrating because it's a little harder to get the vertex. So we're going to talk about that first in this other form. Your book doesn't give the other form a name, but it's the form that we're most probably familiar with. I'm going to call it the general form. I'm going to call it the general form. And it's this f of x equals, if we have ax squared plus bx plus c, right? This is the form that we've grown up with. And we know how to solve this thing, right? Which is great. But now we're going to talk about, well, how do we graph out? How can we pull the important stuff out? Same stuff from what we've been doing so far, and then graph it. And what happens is the vertex is a little harder to find because it's not given in the equation. Okay, the other one, again, it was given, it's nice. So to find the vertex, it's actually a little bit of an equation. First, you've got to find the x value. And I've got to tell you where this x value comes from. This x value actually comes from the quadratic formula. Think back about the quadratic formula, right? Negative b plus or minus square root, all that stuff, right? The very beginning of the quadratic formula is negative b. And then at the very end, it's all over 2a. Okay? That's the x value of the vertex for these. Okay? Negative b over 2a. The y value, you just plug it in. Whatever you find here, you plug into the function. Okay? So we're going to, and I'll tell you too, that a is the same a as before. So if it's positive, it's a minimum. If it's negative, it's a max. Okay, so that a is going to follow the same thing we've been doing. So we're going to just talk about vertex. Let's say I gave you g of x equals, let's say 2x squared minus 8x plus 3. And I'm going to ask you to find the vertex here. We're just going to talk about vertex. Ask you to find the vertex. Okay. So look, first off, we know our a, b, and c, right? A is 2, b is -8, c is 3. So if I want to find the vertex, first I have to find the x value. Well, the x value is, again, it's the beginning of that quadratic equation, quadratic formula, negative b over 2a. Well, our b is already negative, right? So it's negative 8, negative b, over 2 times, and our a value is 2. Okay? So this winds up being 8 over 4. 2. So our x value of our vertex is 2. So if I want to find the y value, I've just got to plug the x value into the function. Okay, it's just g of 2. So it's going to be 2 times 2 squared minus 8 times 2 plus 3. So this is 4 times 2, so we get 8, minus 16 plus 3. I think that's going to be, is that 5? Negative 5? 8. That's not right. 8 plus 3 is, yeah, that's right. Negative 5, right? So you wind up with negative 5. So we got the x and the y value for the vertex. So the vertex winds up being 2, negative 5. So it takes a little more time because we have to follow an equation. It doesn't just give it to us in, the shifting, right? It's not like the shifting before. So 2, negative 5. So now look, again, is this a minimum or a maximum? I'm going to look at the a value, the 2. So I know this is going to be a minimum because the a is positive. So, we're going to shift. It's going to look like a smiling quadratic. That's the word I'm going. Okay. Okay, so let's do another one. Any questions about this before I just give you a few more that are like it? Okay. Ask if you need to. I'm going to give you a few different ones and I want you to try them. And of course, I'm going to go back and I'll work them with you. Let's say we've got h of x equals, I'm going to steal some out of the book. H of x equals, let's say 3x squared minus 12x plus 1. And then all I want you to do is find the vertex. And then let's say like b of x equals, let's say x squared plus 2x plus 1. So try those two, okay? Try those two. Let's try and find the vertex. I'll give you a minute. Let's rock and roll on this one. So the vertex, let's see, the x value, negative b, look, I'm going to be a little lazy. That's just 12, right? Negative b, negative 12. So it turns out to be positive 12. 2 times a, this is 12 divided by 6. So hey, this one's up being 2 as well. That was a coincidence. Now I'm going to plug that in to get the y value, right? 3 times 2 squared minus 12 times 2 plus 1. Let's go to it right here. So that's 6 times 3. That's 8. No, 4 times 3. That's 12, right? Minus 24 plus 1. So negative 24 plus 1, that's going to be, is that negative 11? Is that right? So we get 2 negative 11 for the first vertex. The second one, though, so the x value is going to be negative b over 2 times 1. So negative b over negative 2 over 2. So we get negative 1. Plug that in. Is that right? Negative b over 2. Yeah. We get negative 1 squared plus 2 times negative 1 plus 1. So we get 1 minus 2 plus 1. Hey, this is 0. That's fine. So we get a vertex of negative 1, 0. So it's just sitting on the x-axis, right? This is sitting on the x-axis, and that's not a big deal, but it is. Now, I'll tell you though, for both these, this vertex is going to be the minimum, right? Because the a values are both positive. Okay, no big deal. Questions? Okay, so guys, if you have a question, just ask. We're going to go now. I'm going to go back to that same like A through G thing where I'm going to ask you all the questions. Let me give you one that's kind of nice first. Okay, then we'll get into more tricky ones. Raise this up a little bit. Doesn't look right. Okay, so let's say we've got f of x equals, let's say we got x squared minus 4x plus actually, yeah, let's say plus 3. That'll work. Plus 3. So x squared minus 4x plus 3. And I'm going to ask you all the same stuff. So first vertex. I'm going to leave you more room on this one, right? And then, max min. Leave you a lot of room because we got to do the whole x and y thing. B, axis of symmetry. C, x-intercepts. If we have them, right? We might not have them. I'm going to leave you more room here because this is going to, you're going to have to factor, use the quadratic equation. You're going to do something different here. So I'll leave more room for that one. The y-intercept turns out to be real easy. Y-intercept. E, we've got, was it domain and range? And then lastly, we are going to graph this guy. Again, it's a statement, not a question. Okay, so try these now. So with a different equation, try A through G there. Okay, keep working. Again, I'm gonna start this one. Okay, vertex. X equals, now negative b, so that's gonna be a positive 4 over 2 times a. So no, we've gotten 2 like 3 different times. It's weird. So x equals 2, plug that in. 2 squared minus 4 times 2 plus 3. 4 minus 8 plus 3, so we get, I think, negative 1 here, right? 7 minus 8, so negative 1. So the vertex is going to be 2, negative 1. Now, we know that's a minimum. We got to do maximum 1 for these. Minimum because this A is positive, right? So there's a vertex. Axis of symmetry, just x equals 2. X-intercept, so we have to set this whole thing equal to 0. And look, you can use the quadratic on this one, but I want you to get in the habit of seeing if this factors, because we have to know how to factor for the next few sections, period. Okay, we have to know how to factor. So this does factor. Negative 3, x minus 3, x minus 1 multiplies to get 3 as to get a negative 4. So we set each one of those equal to 0. So x equals 1. So 3 and 1, that's going to be our x-intercepts. And I'm going to write them as intercepts. So 3, 0, 1, 0. Y-intercept is really easy. So you put in 0 into the equation. And notice the first 2 terms have x's. So therefore, they're going to go away. It leaves you with a constant. The constant is always the y-intercept if it's written in this form. So therefore, it's 0, 3. Okay, let's graph it. See what we have going on. We don't really have any big numbers. Make this one a little. Okay, so the vertex is 2, negative 1. We're going to go up. Intercepts are 3, 1. And then positive 3 for the y-intercept. So we know, again, like if you think of this as an axis of symmetry, says, so because the y-intercept's here, we know on the other side we have a coordinate the same distance on the other side. So something like that, right? So our domain, all real numbers, that hasn't changed. But the range, though, goes down to negative 1, and it goes up forever. Okay? Sweet. That's a good question. This is a great question from this section. Okay? Great question from this section. So do you guys have any questions about this? Before I give you another example. Now this next example is going to be a little weirder. This is one that just, oh man, look at these numbers. 2, negative 1, 2, 3, 0, 1. It does happen all the time. Okay. Okay, let's do the paper here. Find another one that just looks different. Let's see here. I'm looking at your homework for an even. Okay, this is 42. 42 on page 343. F of x equals negative 2x squared minus 12x plus 3. So same thing. I want A, find the vertex. We can see that this one's going to be a minimum, right? I'm sorry, a maximum, because it's going to be flipped over. And then give you some room for that. And let's find the intercepts if it has it, x-intercept. The A, B, C, D. Oh, Lord. Let's see. Y-intercept. Oh, I forgot axis of symmetry. That's fine. Y-intercept. Domain. Range. Now let's graph it. Okay, so try those. Now, I don't have axis of symmetry there. If you want to put it in, that's fine. But try. Okay, let's do this. Let's change the colors up. Get a little crazy. So vertex, we got negative b. And so it's a positive 12 over 2 times negative 2, right? So 12 divided by negative 4. Hey, something a little different, negative 3. Okay, so I'm going to plug in negative 3, and I wind up with negative 2 times negative 3 squared minus 12 times negative 3 plus 3. Okay, so negative 3 squared is 9 times negative 2, that's negative 18. Negative 12 times negative 3 would be a positive 36 plus 3. So this would be negative 18 minus 30 or plus 36 is 18 plus 3. So that's 21. So we wind up with, this is going to be hard to graph, negative 321. Okay, probably a rough sketch on this one will be fine. Negative 321, but also we know this is a maximum, so it's going to come back through the x-intercepts, right? Negative 321, it goes down. So if we want to find the x-intercepts, let's see here. Okay, it's a little different. Look, if I'm going to plug anything, if I'm going to try to factor this, or if, it's not going to factor, or if I'm going to use a quadratic equation, I need a positive a. So I'm going to divide everything by negative 1 before I get started. So 2x squared plus 12x minus 3 equals 0. And then I'm going to plug this into the quadratic formula. Look, if you want to use a calculator that has it already in there, you're more than welcome to. I don't care how you do it. I just want you to solve it, okay? 4 times a times c. I'm going to do it by hand because I don't have it in my calculator. Underneath the radical, I get 144 plus 4 times 3 is 8 plus 3 is 24. Wait, 8 times 3, yeah, 24. And then, so we wind up with 168. I think that's right. Underneath there. I'm going to check this just because it's bigger numbers. 12 times 12 minus 4 times 2 times negative 3. Okay. Yeah, 168. Okay, so we wind up with x equals negative 12 plus or minus the square root of 168 over 4. I had to simplify 168. 168 divided by 2, 84. Is that 42 times 2? 21 times 2? 7 times 3. Okay, I can take out a 2. That's it. So I'm left with, I know this is getting kind of garbled up here. Let's start it up here. I got some free space. So this winds up being negative 12 plus or minus. I can take the 2 out. And I'm left with 42. 7 times 3 times 2. All over 4. So this simplifies into negative 6 plus or minus the square root of 42 over 2. Man, if you do not remember how to do this, this is the square. This was solving quadratic equation. It was the very first lecture we did, right? So if you go back to the very first lecture of this class, other than the introduction, you'll see this is what you wind up with. Now the issue for us is I have no idea what this number is. It's 2 different numbers, right? I need to get an estimate so I can graph it. So I'm going to pop both of these in my calculator. I'm going to pop negative 6 plus the square root of 42 over 2n and get an estimate, and negative 6 minus the square root of 42 over 2n to get another estimate. So clear. I'm going to put this into my calculator here. So negative 6 crap, hold on. Struggling with the phone calculator. Minus, let's do plus first. So plus the square root of 42 divided by 2. I got 0.24-ish. I mean, you guys can see, I'm just putting this into my little scientific calculator on my phone. And then let's go back and make that a minus. Minus, I got negative points or 6.24. 0.24, okay? So that's my two x-intercepts. We did all that work for those two x-intercepts, okay? I mean, if you want to leave them in decimal form, that's all they are, 0.240-ish. Now we're rounding. Okay, we'll have to graph this on another piece of paper. The y-intercept, that one's easy. 0.3, it's just that constant. Now the domain's all real numbers. The range, though, let's think about this before we graph it. This negative 321 is a maximum, right? Because it's going to go up and then down. So therefore, the max we're going to go up to is 21, but we're going to go down forever. So it's negative infinity to 21, right? So let's graph it. Don't. Oh no. Run out of paper. This might not be good. Okay. Holy crap. Yeah, I think I ran out of paper. I got one more example that we can do. Hold on. Let's graph this. I'll do it on this piece of paper that I didn't really use that much of. Okay. Man, we're at -3, +21. So -3, and then +21, I'm going to be a little lazy and just say it's up here somewhere. Okay. So -3, +21 is like there. Our x-intercepts are -6.2, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. About right there. And was the other one like positive? So about right there. And then 3 was our y-intercept. So one that does something like this. Okay. Looks something like that. And I know it didn't ask that as symmetry, but it's goes through at x equals -3. Okay. Questions, comments, concerns? Those are all good. You'll see in the homework, it doesn't necessarily ask it like this, but it asks you different questions that look like this throughout the homework. Okay. So it might just ask for the domain and range. Oh, it might just ask for you to graph it. So, I mean, I'm putting it all together in one question to make it a little more efficient with the lecture. Let's do one more, and it's going to look a little weirder. Okay. It's the best way to describe it. Let's say we've got, well, this will be the last one because I'm out of paper. F of x equals, we'll make it easy. X squared minus 6x plus 9. Okay, so the math on this one won't be bad. I don't know, I say that, I don't think it'll be bad. I want you to find, the vertex. We'll add axis of symmetry back in here. Well, actually, let's just add it all in here. Min, max, and then the axis of symmetry. Okay, and then that'll take a little bit. So then let's find the x-intercepts. Let's find the y-intercept. Domain, range, and then let's graph it. Okay. Wow. I goofed up on that one. So try this one. It'll be our last thing. It costs us almost that. We only got like 5 more minutes. So try that one. I'll give you a little bit of time. Okay, let's do this. So vertex, x equals negative b, so that's 6, over 2 times 1. So 6 divided by 2, that's 3, right? Plug it in, and we get 3 squared minus 6 times 3 plus 9. So 9 minus 18 plus 9. Hey, we get the 0. We kind of got one of these in the example earlier. So the vertex is going to be 3, 0. We know it's a minimum, right? Because the a is positive. Axis of symmetry would just be x equals 3. Okay? X-intercepts. Well, that's one of them. Maybe it's the only one. So x squared minus 6x plus 9 equals 0. And we can factor this one. X minus 3. X minus 3. Now check this out. This factor happens twice and it repeats. So we get x equals 3 and x equals 3 as the intercepts, right? You set it equal to 0 and solve. This is actually a repeating solution, okay? So the x-intercept is 3, 0 as well, and it's the only one, okay? It's the only x-intercept, and it's repeating. Something neat happens there. Our y-intercept, we know it's just going to be 0, 9, because it's just the constant. Domain's always all real numbers. Let's graph this. See what this looks like. What's happening here is our graph is, we call this bouncing. It's bouncing off the x-axis. And the reason it's bouncing off the x-axis is because we had repeated x values. So here, repeated x-intercepts, I should say, like that. Repeated x-intercepts. Kind of interesting. The range, it goes down to 0 and then up to infinity. Okay? So for homework, I want you to do, this is on page 343. 1 through just do 1 through 47 odd. Okay. Oh, then I want you to jump over and do 57 and then 59. 57 and 59 are real world problems, are kind of neat. Okay. So try those. My time is up. If you guys have any questions, please email me. Feel free to email me. I will see you all on Thursday.